you guys hear me? Test.
Can you all hear me?
Test.
Awesome.
Test.
Carson, did you pass your test?
I passed my test.
You sure? All right.
I would like to be louder than everybody else, please.
It sounds like that's no. Yeah.
Just eat the mic. Yeah.
Eat the mic.
All right.
Good evening, everyone. How's everyone doing? How's everyone's beach blitz going? Glad to hear. So we're here today to talk about design from different perspectives, and we have a lot of really cool panelists over here, and hopefully this will be very informative. We will be opening up questions, around halfway through the talk, so if anyone has any questions they would like to hear from the people sitting up here about design or anything in general, feel free to volunteer your questions when that time comes. So hopefully this will be informative and useful for everyone here. So just get it started off. My name is Saikaran Ramanan. I am with 3476 Code Orange, and I've been a mentor for the last 5 years. Could you all introduce yourselves and your teams and how long you've been with FIRST? And if you can, your favorite robot. So I think my favorite robot of all time is 469 2013. It's a cool robot. Y'all should go look at it.
I'm Carson Kane. I am a senior on Team 3309. I'm also the president. I'd say my favorite robot of all time is 971 2016. I'm Jonathan Mee. I was the design and build lead on 3647 Millennium Falcons from 2016 to 2019. And my favorite robot, it's hard to say.
You can always go with like R2D2 or something. I didn't say FRC robots.
C3PA is pretty cool. The one with the red arm.
Hey everybody, my name is Ty Tremblay. I'm from New England. I'm on Team 319, and I've been involved with FIRST since 2004, which is long enough, and I'm tired enough that I don't know how many years that is. My favorite robot, I think, would have to be 254 2014, simply just because they analyzed the game, they developed a simple yet effective design, and I actually can't think of a way that robot could have been better.
Mark Wibbles, mentor 2122, started in 2007, so it's been a while. My favorite robot is 1114 in 2008. I don't know if you guys have seen it, but we could all build it in the shop, and it was a super bot.
All right, sweet. Thanks for the introductions. So I guess just a softball question for the beginning, grass tax stuff. But how many people are usually involved in your team's design process, and how do they all contribute to the design as a whole?
So on 319, we have anywhere between, depending on the year, we have between 10 and 20 students, and we've got 3 or 4 mentors. So when we're in meetings, we have probably 4 kids helping out CAD, and then we're constantly just going back and forth and discussing, and we're more arguing about the design. And then I work remotely most of the week. I work remotely most of the week. I live in Boston, and my team's like 2.5 hours away. So after that, we have maybe 1 or 2 people through the week working on it remotely through Onshape.
Do you want us to all weigh in on the same question?
Yeah, I think this is an interesting one.
So for us, it really depends on where we are in the process. But in the prioritization and the game analysis, of course, the full team's there. And then when the mechanical design really gets started and we start making those trade-offs, it's probably about 20 mechanical and probably about 6 or 7 programming team members who are core to that discussion, right? Gathering up mechanisms, working through prototype robots, scoring them, figuring out where the team resources should be spent. So it impacts a lot of people. So I think that there's a lot of people who are in that design.
So that's actually, I think, opens up an interesting question. So it sounds like you're talking about design from an overall perspective, right? Not just the CAD of it. So is design usually driven heavily by your the people who work on CAD, or is it something that the entire team decides upon before even entering that phase?
So I'd say that on day one or day two, we all pretty much have entire meeting with the entire team, and I'd say that we all have like a general idea on what the robot will look like. We do a little bit of both. We prototype pretty much everything except the drivetrain, and I'd say a lot of our parts on our robot are made in CAD and drawn up, but there are quite a few brackets or like mounts that are handmade. So yeah.
Okay. Yeah. Should like to hear from Paul.
Oh, we can hear from you too. You're
I guess for us, we kind of just cobble together a lot of things. So the entire team's usually involved in the entire design process, and it's the CAD students who kind of put it all together. But it sounds like, actually, I'd like to know how 319 does it.
Yeah. I think I found the exact. It works here, but not here. Got it. So 319 actually breaks the robot capabilities down first. So we sit down, we get together, and we decide what's important for the robot, and we break it into wills, shoulds, and maybes. And so the first thing that gets done is the wills, and then we look into the shoulds. And if we can find a way to squeeze a maybe in, or get a mechanism that can do a will and a should and a maybe all at once, then we'll go for that. But the real core driving concept for 319's designs is the wills. So for example, in 2016, 319 said, we will score, we will fill the rocket. But then we had I think it was like a should or a maybe for scoring high. And up until championship, we just couldn't score high at all. And we were just a low bot all the time. And we found that limited us, of course, because come district championship, we were just left in the dust. But still, it got us our first blue banners ever. So we've been keeping that system since then.
Okay. So actually, Jonathan, how do you all decide what you all want to make on your robot? Because I think a good example is, I think everyone here had a climber, except for Millennium, but Millennium seems like they spent a lot of those resources into making a fantastic looking arm. And it got you three blue banners, which is really cool.
Yeah, so we do something similar to what 319 does with the must-haves, the maybes, the shoulds, and the maybes. We list every single thing down to like robot movement, ability to play defense, stuff like that. And this year, I think we sort of didn't prioritize climbing as much as we should have. We did have a climber at one point, but we couldn't get it working that consistently, so we had to take it off. But yeah, we think about, the entire game as a whole and what we need to do in order to win matches and then win events, whether that be us picking or being picked by other teams.
So that's actually really interesting. So we also do we call it preferred wish demand. So do the rest of, do you all do it, Mark?
Could you repeat that? You called it what?
So we call it preferred wish demand. It sounded like you called it.
Yeah, we called it will, should, and maybe.
Yeah, we do a demand, wish, prefer.
Okay. How about 21-22?
So recently we've been very fortunate in that we say right from the very beginning what's it take to win the whole thing, and what's it take to beat and name the team 2056, 54. Do we have confidence that at the end when we're building that we're going to be at that level? And we've kind of given up on that. Probably should go back to that, because as the team resources change, you have to scale appropriately, and that's a scaling process. I like it. It's great.
Yeah, I think we did that this year, actually. The worst time is we did it back in 2017, where in 2016 we got left behind, so in 2017 we decided, all right, look, let's go win the championship. But the problem was we tried to win the championship in week 1, and we lost that event, we lost the next event, and the next thing, we didn't even make it to district championships. So we pulled back for 2018, and then we tried it again this year for 2019. We tried to make a robot, and we got a lot closer. You know, we lost that final third match to get to Einstein because our battery cable was loose. But like, yeah, I agree. Like, I think that there's like that middle ground between what's it going to take to win, and rather like, what do we think is going to be effective?
That's an interesting point. So I'd like to say, so for Team Taters, I think y'all have been on Einstein 3 times, 4 times? 3 times? So it seems like this approach has worked pretty well, and most notably this year they won, Hopper? Okay, yeah, they won Hopper, and that was quite impressive. So do you actually plan on changing this process for the next year based off of your experiences this year, as well as how will the lack of the 6-week restriction change all of your processes?
So it's a great question. In the first regional, who beat up on us in the first regional is here. We qualified 24th, and we couldn't get on top of our robot. Yeah, no, they beat up on us on the second one. Yeah, they beat us in the champs on the second one.
But then we got you guys wild carded it.
Yeah, we appreciate that. Third regional, you know, it took us a long time to get on top of the robot. We felt very lucky. You're fighting all the way, and I think we're all going to fight all the way because we're going to be building right to the very bitter end amongst this set of teams, I think, next year.
Well, you guys can fight. I'll just be in Detroit.
Champs, 4 champs from 2020, 2022, right?
Yeah. I think the no bag changed a lot, and I think we're gonna double down on this concept of modularity, in that we're gonna take what 21-22 did and say, what's it take to win the whole thing? But at the same time, we're gonna ask, what does it take to win district championships? And then also, what's it take to win in like week 3 and week 1? And I think with no bag, you can build a robot that can start out as the robot that wins in week 1 and evolves until it gets to the robot that wins world championships.
So actually, 3309, have you made any plans for the no bag and how that's going to change your process?
We really haven't had a meeting yet, but we do have to have a few meetings about how we're going to do it. But I think we might just stay the same. I think we'll try and follow the 6-week schedule and try and finish it within then. That will give us some time. And since our first regional is at week 1, we really want to finish it really fast.
Yeah, so on our team, I don't think it's going to change our process that much, because during like the past couple of years, when Build Stop ends, we keep working just as hard all the way through all of our events, and because we built 2 identical robots.
Okay. So kind of on the same topic and shifting gears a little, as I hope everyone knows that we're not doing a bag next year, or FRC is not doing a bag next year, so another robotics competition that does this is VEX, and we see in VEX that there's a lot of, more people are closed with their designs. And on that topic, 319 is really cool because they have open design. Their CADs publish all the time on Onshape throughout the entire season, and you don't really see too many teams do that. So I'm wondering if, are y'all going to close down more? Are you guys going to open up? Are y'all, for everyone here? But
Yeah. In my opinion, a secret design is not really a competitive advantage in first, unless you're pulling off like a 469 in 2010. For those of you that don't know, you had to score balls into you had to kick soccer balls into the goal in the end, and then you could take those balls and you could put them back onto this like ramp thing that would dump the balls in the middle of the field. So 469 built a robot that would just catch the balls off the ramp thing and kick them back into the goal, and it just became this infinite loop where typically matches were like really good matches were scoring in the 10s. You would score 10 points. These guys were scoring 30, 40 points, and it was amazing. And if you put that as an open design, then it kind of loses its magic. And I think, but for us, like, First isn't going to design a breakable game again. So for us, we're just going to be open. First Robotics is about inspiring people, and if we can help other teams have an effective design, then that's what we're here for. We got beat by our design for the first time this year. 176 had some like integration problems, And they ended up taking like some of our design concepts and they were worked, and they put them on their robot, and then their robot ended up beating us. And I just think that that's cool. District champs, like a design concept beat us, but we're cool with it.
That's really interesting. I think another good example of that is all the wheeled hatch mechanisms. So it seems like I think everyone except you all did the wheeled hatch mechanisms. Your redesign has it, but it's really interesting to see how that kind of stuff spreads. So during season, I guess Mark, do you all share things with other teams? Do you try to develop everything internally? Do you look for outside help for design?
We do it all internally, and there's such a contrast between us because our system is going to be very challenged, of course, with the new build things, but we try to keep our design kind of to ourselves, and we don't have a lot of teams around that we collaborate with. It's very different in the Bay Area. You see all those California designs, they populate so quickly because of all the events, and so we're actually kind of inspired to do it differently. We take pride in that, and it spurs us on, and that's part of the inspiration for us. Copying, we like to go to regionals and look, early and see, learn, but we like to win, and so the competition is the core of the inspiration for us.
Carson, how do you?
So in the season, there's a team called 4414 from Ventura. A few of our mentors helped start, and they helped mentor them. And unfortunately, they can't really prototype that much. They couldn't this year because we have a large inventory. We have a ton of wheels. We have a ton of geared separate parts that we have prototype. So we help them prototype, and we sent our prototypes to them. We also had the idea of the side elevator, and the same. We passed that along to them, and basically, we didn't look at each other's CAD throughout the season, and when we saw each other's robot look very similar, because basically we prototyped the cargo claw, we prototyped the elevator, and we prototyped the mechanum intake, and basically it all came together, and our robots look pretty similar.
Was that a detriment to you guys, or was it interesting, or did it hurt you all in the end?
I don't think it really hurt us. We never played them in season, so I thought it was really interesting.
I guess never play with teams that you collaborate with. So, Millennium, there's a big community of teams in San Diego.
Yeah. Funnily enough, we don't actually collaborate too much with teams in the local area. We have teams come to us and we go to other teams for practice, but when we start off the season, everything we do is pretty much to ourselves, but then as the season goes on, we'll talk to other teams, and then we'll, share things that worked and didn't work.
For 319, I think that the open sharing is only making all of the other teams better. I think it's the rising tide raises all boats concept. For example, 3847 Spectrum out of Texas. They're also a very open team, and they have a blog. It's really, really great. If you guys don't follow Spectrum's blog during the season, it's a great source of information. Alan Gregory runs a really tight ship over there. They posted this collector for the cubes, and it looked great. And they were like, "Here's the design." And then I downloaded the design, and we played around with some stuff and changed it around, and we ended up making one that was better than Spectrum's. And then Spectrum called us up, and they were like, "Hey, you got the CAD for that?" So we gave them the CAD back. So it ends up with this mutual thing in which both teams get better and both teams get to learn. And I don't know. I haven't found a reason to stop yet.
That's really interesting. I think from a Code Orange perspective, we've been we share things with our friends and with some people that we know, but we want to get more open because I think we like how you all so Spectrum this year actually they won a division with 148 and they were phenomenal. They shared a lot, and I don't think they got beat by their own design this year. But it's also really interesting to see because I think you guys in Spectrum had Chinese copies at the Chinese off-season events, right?
Yeah, that was really cool. It was I think it was 5308, I believe, or that basically just took our CAD and just made it, and it was great. We actually invited them to our this year in 2019. And they joined us from China. They woke up at like 4 o'clock in the morning and called in, and we talked about the game and broke it down with them. And then they went and made a copy of somebody else's robot. Yeah, I was quite offended.
That's a that's a really fantastic example of how the rising tide helps all ships, right? So I guess we're at 6:30. Does anyone from the audience have any questions? And if you all do, feel free to come over here to that entrance and line up behind Rocket, and you can ask your questions. So you can do that right now. I'll ask another question by the time you all queue up, if anyone does have a question. But we had an interesting autonomous mode this year where it was hybrid. We had a sandstorm period, so people could drive the robot as well as use traditional autonomouses. So how did that affect your designs? So Millennium.
So actually, our entire thing with the flipping the arm, it wasn't just for teleop. We have, for the past couple of years, we've had pretty weak autonomous modes, and so we tried to make it easier on our programming team by having a way so where we didn't need to do any spinning moves or stuff for auto. Just drive forward, place a hatch, back up, pick one up, and go forward and place another one. So that led to us really pushing for being able to score from on the front and the back.
So interestingly enough, I think everyone other than 3309 here had some sort of capability of flipping your mechanism, right? So I guess why did you all do it? And second point to that, did 254 last year inspire that in your robots? Because I think it inspired it in a lot of teams where they saw how effective the poofs were at flipping their mechanism backwards to get around defense or to do autos better, and it looked like a pretty good solution to this problem as well. But yeah, Carson.
So we actually planned to do the flippy arm in our initial meetings. We took the inspiration from 3538. We saw them at Chili Champs, and they did really good with it. So that was one of the reasons we did the side elevator. But basically, throughout the season, we figured out that it's one more thing to add, and we're not super great at flippy arms like that, and we really didn't want to add an arm like that in between regionals, so we just kept it the same.
Did y'all have anything about the inspiration for your robots?
Yeah, we didn't really flip anything around. We just made it so that we could shoot through, and that was basically exactly taken from 254, and also from 2122. I took a long look at 2122's rebuild from last year. Got a lot of pictures taken, or a lot of pictures sent to me, so that I could figure out how they route the cables. And honestly, I wish that we had gone the 3538 route from this year. I wish that we hadn't done a pass-through. It made our robot too complicated. I think there's something to say, but for teams like 3538 and 2056 that build a robot that seems to be simple, but they drive it to its absolute limit and to its absolute best, where they don't need to put like a 4 degree of freedom arm on an elevator on a turret in order to...
You're calling me out there, I guess.
I was calling out 254.
I think that's interesting. We have a lot of people back there, but just as I think there's really something to say about making your robot bulletproof, right? So 2056 is a good example where they've only lost one regional, and they make pretty simple robots, from a bystander perspective, but they're bulletproof. So does anyone else here have anything to say about how they got inspiration for their robots?
Yeah, same with 3309. We saw 3538 at Chili Champs last year, and that was what we took a lot of inspiration from.
Of course, we're tracking those robots, and we love the simplicity of the drive. If you can flip the mechanism in parallel, the control of the drivetrain is much simpler. We think that's a win. But so
Definitely.
Of course, yeah.
It definitely is. So I'm going to open it up to the audience. So if you'd like to introduce yourself and ask your question.
Hey, I'm Tommy Smeltzer with Team 1138.
Just step around here.
Sure.
We...
So you can see my name.
There we go.
So I kind of have a two-part question. First of all, I'd like to know at what point in build season you guys just absolutely lock down the CAD and say this is what we're building. I'd like to know, kind of where you are on the scale of creativity in design versus things that you're comfortable with. We often go back and forth on given the tightness of our window to, to go with something that we know that will work versus something that we think will work. And sometimes your prototypes give you some information, but might still not, it might be a little outside of your comfort zone. So I'm kind of curious about how you guys feel about working outside of your historical comfort zone, given the tightness of that window.
You can try. There's a lot there. Well, we're kind of we struggle with that too, and so we build these off-season bots. We want the toolbox as full as possible because we want reference mechanisms on everything. We want to be able to walk up in our pole barn and say, that bot, you've got to build something better than that, or we're going with that mechanism, something like that.
In terms of the lockdown CAD thing, it's basically when my lead mentor threatens to kick me off the Onshape team. I think so. There's always there's a saying that one of my professors at WPI used to say, in which perfect is the enemy of good enough, and if once it's good enough, then ship it. So what we do is we figure out when do we want to have this drivetrain working. Okay, cool. How long is it going to take us? And we work back, and that's when we have to decide things. But when it comes to experimentation and coming up with what works and what doesn't work, basically 319 has this really unfortunate cycle where every other year we get more aggressive and we play with things that we think might work or we try to push the limits. And then the next year we're like, whoa, well, that was a mistake. Let's pull back. So we pull back and then we just kick butt and it's awesome. So we're like, cool, this is great. We're the best team in the world. Let's get aggressive. And then we're worse. So that alternating year, I find over the course of the years, the amount that it changes has been settling, which is cool. In 2014, we made this crazy simple robot. We made it to the championship for the first time ever. In 2015, we made something. And we made it to the championship, but it took a lot of work. We basically had to rebuild the whole robot. 2016, maybe very simple robot, made it almost, got onto the #1 seeded alliance and got kicked out and lost to these guys. And we were like, oh, this is awesome, this is great. 2017, let's go win the world championship. We didn't even make it to district champs. So we find that there needs to be some sort of checks and balances there.
So on the same topic, for Millennium, I don't know if you all know their robots from the last couple of years, but their 2017 robot was, I'd say, pretty simple.
Yeah.
But it kicked major butt, and then the next year you all had a crazy robot last year, but it wasn't. It seemed like you were, because we go through the same process where we have a sine wave of where we go too complex and not complex enough. So how does it affect you all? Because it doesn't seem like it's that big of a factor.
Yeah, so in 2017, in the previous 2016 season, we had almost all of our seniors leave, and so 2017 we were definitely short on manpower. So we decided we wanted to do something really simple and just be able to play the game. And we thought gears, that's something that you need. But fuel on the other hand, it's pretty difficult. So we decided just to completely skip it. And then 2018, because of our success in 2017, we tried to push harder, but we had, just a lot of small things in general, that little details that we weren't able to quite work out because we had tried to make everything, really push to do everything on the field. And then in 2019, we learned from our 2018 mistakes, and then we were able to just go do exactly what we wanted.
Okay.
Yeah, so I'd probably say that we're the opposite of Millennium Falcons. So in 2018, we built a generally pretty simple robot. We really didn't have any problems with that past week 4, our second regional. And maybe there was a few, but that was about it. And then this year we did the sideways elevator, and that gave us problems all the way up to Worlds. The characters coming out,
You mean all the way up until the last match you played, right?
Yeah. So the carriage coming out, the climber was deploying. There's just a lot of things going on, and we kind of at Worlds it was all right, and then here we had it came out again. But yeah, I'd say if I was to do another elevator game, I would definitely go with another traditional elevator. the sideways elevator took up a lot of space in our robot. Make other compromises regarding the climber. But yeah.
Yeah, I think those are good responses. We're going to go back to the audience questions. So I think we have around like 10 minutes left, so we might want to condense the responses a bit so we can go through them a little faster. This is, I think, all really good discussions.
Hi. Hi, I'm Clarissa from Team Sprocket 3473. I was wondering, for your guys' design, where do you guys all pull together a design from like your past robots, from just spontaneous, let's go try this out, let's go do it, from your mentors who have more experience, or from past robots of other teams, like where do you guys all pull that together from?
So I'd say that like past robots helps a lot. So our cargo intake, it was inspired by 971 2016. Did a little mechanism intake, and it took about like 2 days to get it perfected, and that really helped a lot because we didn't have to spend too much time on it. Yeah.
So actually, just like a quick, I guess I've got a question for y'all, but like just raise of hands. For your robot this year, did you all model it heavily based off another robot's design, or like get inspired heavily from another robot's design? And I'll put my hand up for this. Did anyone else here get like heavily inspired by another team? So it seems like from the entire thing, it seems like 2122 likes to think of things internally, right, and approach things with a fresh perspective every time. Does that sound about right?
Yeah, but we of course have this toolbox we draw out of, right? So we only invent those things we have to invent because the schedule's so short and we're so small. We have to have reference designs for everything and then limit the newness as much as possible.
Just a quick aside, for I think one of our coolest mechanisms of all time is our 2016 shooter, and that was a straight copy of the 2014 254 shooter and the 118 2012 shooter. Just a combination of that. So, but like I think it varies for everyone, but we draw a lot upon other teams' designs.
Yeah, it was, well, the next question is coming up. Like, our elevator this year started as a copy of 254's 2018 elevator, and then we decided that we also wanted the elevator to go down, and then after that, we had to reinvent everything because we make bad decisions.
Hi all, my name is Andrew. My question for you is, when it comes to design, we all know the devil's in the details. A lot of us are either here with teams or volunteering, and we can't get to see all of your robots up close. What's a really good engineering detail you're either proud of or think we can learn from your robots?
I think it's on your robot, if you have like the manpower and the time, it's to just model everything. You know, everything down to the bolts and the washers.
I'm asking about your robot specifically.
Oh. I have to say, one thing that I really like that we did that was new for this year in terms of our design was we like to do like reduced size gussets. So the previous years, if we had like two 1x1s connected, we would have a 1 inch by 1 inch wide gusset, and then this year we like to do smaller, like slimmer ones that were only 1/2 inch wide. So that saved a lot of weight.
That's a really interesting thing because I've taken a lot of look into your robot, and your entire spinning mechanism is fantastically cool and like not too complicated. So I would assume it would have been that, but it's really cool that it's the gussets, right? It's the details. The rest of y'all?
So we made a robot that just basically had to be empty in all of the places where the robot was supposed to be, and that was like this year was just a packaging nightmare. And we had this big beefy arm on the front. We called it the big beefy arm. And when we originally designed it, we had to keep everything separate because we wanted to be able to pass the ball through. So we needed motors on the left and we needed motors on the right. Couldn't put anything in the middle, and so it ended up forced us to design like a 400-to-1 gearbox that could like fit in my palm of my hand. And it was like, how did it go? It was a 775 through a belt reduction into an inverted versaplanetary, into a gear, and it just kind of like hopped back and forth. It was great. It's all on Shape. You can check it out. But that was like the least favorite part of my robot until, and that's because we thought that we were 971, and that we could control two independent parts of our robot that were like mechanically linked with just software. And we bent so many sprockets and wrecked our arm. So one of our students came up with these little like couplers that we could 3D print that allowed us to like put this coupling shaft between the two. And that little tiny thing is like my favorite part, because all it was like, it's like a slightly enlarged hex shaft, so they can slide the couplers in along the shaft and then pull the whole middle shaft out. And then the two parts are separate, but obviously we're not 971, so we can put that in and not have to worry about the software control.
Interesting. Mark?
I think the world changed this year, and we're learning about it at this event. And I think one of the coolest things on our robot, things I like, is something that we ended up borrowing from 1619, and that little vacuum that they built. Oh my goodness! If you haven't built one of those, you should grab yourself an automobile pump and a couple of 775 onto the back of it and suck. And you can do funny robots like 971. The world changed for everybody, and if you can't do it, you should steal from us very quickly.
Preston?
I'd say my favorite part of our robot is our climber. We had a really big packaging nightmare. So a lot of space. We had this very small amount of room that we could put our climber, and we demanded a level 3 climb. So it's basically like this really tiny thing that's in the middle of our robot, and it does all these things, and it all folds up into this nice little rectangle.
Hi, I'm Michelle, and I just wanted to know, how did you guys build your climber for your robot?
Through lots of pain and suffering. I'm a big fan of mechanisms that can do two things at once. So for example, our big beefy arm is our ball collector, and it's also the first like one half of our climber. And it's got like this 19-inch arm, so we had to put this huge gear reduction on it to make sure it was strong enough. And then like our collector is also the thing that pulls us forward on the HAB 3. And it was almost our floor hatch picker-upper, but I didn't quite pull it off. And then our elevator is it goes up, and then also we can convert it to go down to lift the back half of our robot up. So when it came to that, it was basically just trying to combine as much as possible. And I wish we had taken a different route, in that I wish we had just like put another mechanism on the back to lift our robot, and 73 did.
So Mark, for Taters, from what I remember, your original climber was also based off the elevator, correct? Your main spring elevator. Do y'all regret that, or is that a good decision? Do you think that's a good decision in hindsight?
So we made trade-offs because when we modeled the time for the game, we needed to flip over, and because everything that we looked at, we were faster if we flipped, and we had a high-speed flip, and more elusive against defense. So when you flip over, as Millennium knows, a lot of your robot gets taken up by your mechanism. And we weren't that good at flipping over. We had two independent lifts on the side and took the whole center of the robot, right? Because we wanted to flip both cargo and panels. We weren't clever. We didn't do a side system. So we were desperate. And so we had to do a chain lift, 4-corner chain lift with hex shafts across, and stand up on 4 posts and drive a back roller. And it was really desperation. You know, shoehorning. I see a lot of shoehorning for other robots. You know, you've made these trade-offs to get this core function, and then you do what's expedient. It's all you can do, right? And it was all we could do to do
Sure.
that lift.
It seems like it worked out well. I think we have one last question.
Hi, I'm Karen. So I'm curious how you guys get your teams ready for build season. New students, maybe kids that are coming up where, kids have graduated. How do you prep your teams?
Really good question. So how do you all prep your designers to design a robot? And actually to get that started off, 2122 showed up today with a completely different robot than the one they had on season. And it seems like that's a big part of what y'all do, because you did that last year too.
Yeah, that's the core of it for us, right? If it was football, we'd be violating contact rules, because our kids have to. We're a small team, and the kids need the the sophomores have to build like juniors, and the juniors have to build like seniors. So we build more machines than most.
Now, here comes my Onshape pitch. So, Onshape has this great educational track that you can follow on learning how to use their software. But the big thing is that it doesn't also teach you how to CAD. And you really just can't design a set that can teach anybody how to CAD because the design spaces that CAD software is used in is just so varied. So yeah, we do something similar to 2122 where we'll design off-season robots, but we also sometimes will just sit down and be like, okay, look, here is, like 254's mechanism from X year, or here's the 2008 ball. How would you pick this up? So we find that instead of being like, okay, freshmen or sophomores design a whole robot, it's like, here's something that's already designed. Now let's go through it and figure out why it's designed that way.
We have a couple more minutes, but just so you two, Jonathan and Carson, so Jonathan just graduated, and Carson, you're still a student. So how did you both get good at designing, and how did you all, improve and get ready?
So I basically learned the software by just playing around with it. We use Autodesk Inventor. A few of our mentors know how to use it, so mainly why we use it, and I just messed around with it. The way I learned designing, I basically looked at a ton of robots online. I researched a lot of them. I'd usually ask for pictures. I'd go around competition and like asking teams like, how'd you do that? Why'd you do that? And like just try and get a bunch of information from other teams.
Yeah, so in our team in 2016 when I joined, all the seniors left and all of us freshmen were sort of just like, what do we do now? And so we had a huge core group, that freshman group, through all 4 years, and we all sort of just learned from each other and learned from online, had to just learn it all ourselves.
So trial by fire, I guess, right? Yep. Just make the robots and see how they learn from there. I wish we had a lot more time. Thank you all for being here. I think we learned a lot, and I definitely learned a lot. And thank you all for coming. So I think that's the end of tonight. And we have another panel here about drive coaching, I guess, after this. So feel free to stick around for that. But yeah, thank you all so much.